Now is we're just going to work with radicals. Radicals are usually taught in Algebra 1, and sometimes you see them in geometry. It just really depends on the teacher. And so I just wanted to spend a day practicing this, making sure we know how to do it when we start getting to more difficult radical problems. So a radical is just a square root, or a cube root, or a fourth root. If you don't see a number there, you need to know that it's a square root. And why that's there is because it tells you that you have to have pairs. Things have to have a partners. So if I have a problem like this, it's a lot of numbers, but in order to take any numbers out, they have to have a partner. So I have a pair of threes, so that means I have one pair of threes, so I will write 1 3 outside. I have a pair of sevens, so I have one pair of sevens, so I write 1 7 on the outside. Now this does not become 37, this becomes 3 times 7. And then underneath what's left is a 2 and a 5. Well, outside numbers go with outside numbers, inside go with inside. 3 times 7 is 21, and 2 times 5 is 10. And that's it. So what's going to happen now is that we're going to have to use factor trees to get something to look like this, so that we're able to take out partners, and then we're able to simplify at the end. All right, well, when I look at 4, the square root of 4, well, that one's pretty basic, and I think most of you know the square root of 4 is 2. But let me just show you why. It's 2 times 2. I have one pair, so I write 1 2. Same thing here with 5. The square root of 25 is 5 times 5, so I have 1 5. Now 18 is when we finally get to one that doesn't work. 18 is not a square, so I have to do my factor tree. And I think what two numbers go into 18? And there's a lot of different ways you could do it. 18 is 2 times 9. That's not a pair, so I got to keep going. I can't break 2 down, because I would just get 2 and 1, which really doesn't change it. But I can break 9 down. 9 is 3 and 3. So if you notice, I look at these bottom numbers. The bottom numbers, the leaf numbers, are what I use. And if you see, I have one pair of 3s, so it goes on the outside, and I have 1 2 left over, so it stays underneath. Okay? So why don't you pause and try the next 3 and see how you do. Okay, so if you look at the first one on the left, 50 is 2 times 25, which is 5 times 5. I had one pair of 5s, so it came outside, and I had 1 2 left, so it stayed underneath. For number 5, 27 is 3 times 9. 9 can be broken down again to 3 times 3. I had one pair of 3s, so 1 3 came out. I had 1 left over that wasn't paired out, so it stays underneath. All right, 72 was 9 times 8. 9 times 8, so that makes it 3 times 3, and then 2 times 4, which makes this 2 times 2. I had a pair of 3s, so it came out. A pair of 2s, so it came out. But then I had a lonely 2 here underneath, so it stayed underneath. And 2 times 3 is 6, so it's 6 square root 2. Okay, what we're working now is radicals. We're still going to have to simplify, but now radicals is a special rule, and you have to be able to understand how this works. The issue with radicals is you're not allowed to have a radical or a square root on the bottom. Not allowed. Okay, so let's do an example. And actually, let me write some hints up here. This is what I want to do. My hints is always try and reduce first. If you reduce first, it's going to make a huge difference because your numbers are smaller and it'll be easier to work with. If you don't reduce at the beginning, you're going to have to reduce at the end, and they tend to be harder problems to reduce. Okay, so let's look at number 7. Now, in order to take something out, you had to have 2 of them. Well, I only have 1 5 here, so I need to have another square root of 5. Well, a fraction is similar to an equation. Equation, if you do one thing to one side, you got to do it to the other side. A fraction is the same idea. If I do something to the bottom of the fraction, I have to do it to the top of the fraction. And so 1 times the square root of 5 is just the square root of 5. I have a pair of 5s here, so they come out. And that's the answer. All right, for number 8, I have to have another square root of 3, so I put it on the bottom. But what you put on the bottom, you got to put on the top. Now, over here, 1 times square root of 5, that was easy. It was just square root of 5. This one, the tendency is going to be to make this 6. But this is an outside number, and this is an inside number. They don't mix. They have to stay apart. So what I really have is 2 square root of 3. I have 1 pair of 3s, so that goes over 3. All right, number 9. I said to reduce. That's the only hint I gave. But you can't reduce if things are in and outside. They have to be in the same position. So since these are not in the same position, I can't do anything right now. What I'm going to do is I'm going to get rid of that square root of 10 by putting it on the top and bottom. 4 times the square root of 10 is 4 square root of 10. I have 1 10, so I have 1 pair of 10, so I can write 1 10. Now, if you notice, I have some numbers that can be reduced that are both on the outside. So I need to reduce these. 4 over 10 reduces to 2 over 5. So the answer is 2 square root 10 over 5. Okay. For number 10, this is one that we can reduce because they're both inside. And if I don't reduce it, you'll get the same answer, but it's a lot more work. And more work sometimes leaves more room for error, and we don't want errors. So if I divide both of these by 5, I get the square root of 2 over 3, which really is the same as the square root of 2 over square root of 3. So now, why don't you see what you could do to get rid of that square root of 3? So you should have multiplied by the square root of 3. You see how both of these are under? Since they're both under, I can actually do the math. So 2 times 3 is 6, so it's the square root of 6. I have 1 pair of 3s, so it's 3. Why don't you try 11 and 12 on your own so that way we're able to go over it and you can see how you did. So here we have square root of 1/2, and I work it out. I multiply by the square root of 2 on top and bottom, so I get the square root of 2 over 2 because I had 1 pair of 2s. For number 12, this one was actually relatively easy because 33 divided by 3 is 11, and you have no radical on the bottom, so you're good to go. All right, so remember the rules when dividing. You cannot leave a radical on the bottom. You have to take care of that by kind of moving and multiplying it at the top. And remember, my one hint was to reduce at the beginning. It'll save some time. And then when you're simplifying, remember that they have to have partners. And when you have a partner, that one partner can go outside, and what's left over stays inside.